Hello, my name is Bhaskar Vira. I'm at the Department of Geography at the University of Cambridge. I'm looking forward to my lecture today, which is going to be about the political economy of conservation and food security. In today's lecture, I'm going to be really addressing the difficult challenges of growing enough food to feed all the hungry people in the world, while also trying to preserve biodiversity and nature for future generations, and the difficult choices that we have to make in order to balance those competing objectives.
Welcome to what I'm afraid to say is the last in our 2022 Darwin College lecture series, where we are, of course, exploring the theme of food. And we've heard a variety of distinguished speakers spanning the arts, sciences, humanities, and industry so far, and we have one more to go. So the overarching theme from all our speakers has emphasized the past, present, and future importance of food in addressing a whole range of global challenges. In the context of what is now a world population of over 8 billion people, nearly 8 billion I think at the moment, but rising of course, we heard early on from Sarah Mukherjee and Richard Palmy about the increasing number of both challenges but also innovations to address food production and distribution. And then we step back in time. Those of you will recall who were here when Melissa Calarezu examined food as a source of identity in early modern Europe, and then Martin Jones last week unearthed the fascinating prehistoric spread of crops across Eurasia. Unsurprisingly, the role of food in influencing climate change was the basis of a number of our lectures. Sarah Brindle, our first lecturer, a professor in food and climate science, the veterinarian, Andrew Wright, and our local chef, Alex Rushmer, all emphasized the importance of food and considering its ethical and environmental impacts, looking from entire societies to individual restaurants and individual people, and indeed to what our pets eat or what we choose to feed them. Today's lecture comes full circle, and we're exploring some of the issues that frame the choices in relation to food security and conservation of biodiversity, that is. And so it's a great pleasure to have Professor Bhaskar Vira to discuss the challenges of how we can ensure equitable access to nutrition for the human population without undermining the planet's life support systems. Bhaskar is the head of the Department of Geography and a professor of political economy at the University of Cambridge. Within the university, he's a Fellow of Fitzwilliam College and an Honorary Fellow of St. John's College, and the incoming Pro-Vice-Chancellor for Education starting in October this year. He was the founding director of the university's Conservation Research Institute and is a trustee of the United Nations Environment Programme World Conservation and Monitoring Centre. In 2018, he was awarded by the Royal Geographical Society the Busk Medal in recognition of his extraordinary contribution to interdisciplinary research on the environment and development. And in 2021, he was elected as a Fellow of the Academy of Social Sciences. Bhaskar's research is fascinating. It examines the ways in which societies engage with land and nature, and the political and economic contexts in which communities, businesses, and policymakers make choices and negotiate trade-offs. He has contributed extensively to global science policy processes and dialogues in the context of food and agriculture. And more recently, he has chaired the International Union of Forest Research Organization's Global Forest Expert Panel on Forests and Food. In addition to all of that, he somehow manages to find time to not only watch but also play cricket and enjoy walking in the Cambridge countryside, and I hope beyond, with his partner Shiraz, who I'm delighted to say has joined us this evening, and also with his dog Milo, who I don't think has joined us. So, Bhaskar, thank you for coming today, and please join me in welcoming him to give his lecture on the political economy of conservation and food. Thank you.
Mike, thank you very much for this extremely kind introduction. And I'm also grateful to you and colleagues at Darwin College for this singular honor and privilege at being asked to speak at the Darwin College lecture series. My wife Shiraz and I have been attending the Darwin lectures since our time as students in Cambridge many years ago. And it is testimony to the imagination and foresight of generations of organizers, fellows and students at Darwin College, that this series of lectures continues to occupy such a central space in the intellectual calendar in Cambridge. Fridays in Lent term, Lady Mitchell Hall, has been a regular feature in our diaries for many years. And it's wonderful, of course, to be back here in person. And also great that the wonders of technology enable so many others to join us online. So these Darwin lectures embraced interdisciplinarity well before it became a fashionable term. And it's to your credit that you got here before others did. It takes great intellectual creativity to pull together 8 speakers on a theme and to allow them free rein to interpret their remit in ways that speak to each other. The themes that you've chosen across the years have been fascinating. And of course, it's my distinct privilege to be here today as the final speaker in this year's current series on food. As Mike has said, my own topic is the political economy of conservation and food security. And I hope what I say helps to tie together some of the fascinating strands in the talks that have gone before me. So thank you very much for this, and I look forward to speaking with you. So as Mike indicated, there are some really powerful global trends that have been driving some of the concerns that I'm going to be talking about in the course of this lecture. And I want to start with a few of them to set up some of the issues that I'm going to address. And I'll start initially by talking about a number of sort of recent reports that have pointed to the state of the planet and the state of humans and our life on this planet. The first of those is the World Wildlife Fund's Living Planet report, which documented that over the last 50 years, we've seen a significant decline in the state of biodiversity, the state of the biosphere, our living planet. And that sets up one of the initial contexts in which I'm going to be trying to speak about the challenges that we face thinking about the 21st century. In parallel, this diagram has become quite popular, at least amongst the scientific community. It talks about planetary boundaries. So just like we've talked about the decline in biodiversity, the planetary boundaries framework talks about the limits, the biophysical and geochemical limits that frame life on Earth, that allow life on Earth to sustain itself. It's things like climate change, it's things like ozone depletion, ocean acidification, biochemical flows, freshwater use. This is the biophysical context in which we have to sustain ourselves. And the planetary boundaries framework was proposed to try and examine what the state of play was in relation to a number of these critical variables. And the framework looks at how safe are we in terms of breaching the acceptable limits within these planetary boundaries. The news isn't all that good. We've probably breached 3 of the boundaries. We think we are operating in the risky zone for a number of the others. And the trends themselves suggest that we are at risk of exceeding some of the others as well. Our economist colleague, Partha Dasgupta, pointed out in a very important review that was published last year that these declines in planetary systems are paradoxically taking place at the same time as human prosperity, at least superficially, seems to be better than it's ever been. That's a graph which shows the rise of GDP from 1750 to the present day. There's never been a better time to be alive, according to that. Would you rather be alive in the 21st century or in 1750? A lot of quality of life indicators also follow the GDP trends. Life expectancy, mortality, they all seem to be suggesting that paradoxically, this 21st century is a better time to be alive, even though the planet is in peril. And that's the paradox that he's trying to address when he's thinking about the economics of biodiversity. I will come back to his review towards the end of my talk. A parallel framework by another economist has been called the economics of the donut. And donut economics has become a really popular phrase. It uses the planetary boundaries framework, which I've already introduced in terms of the biophysical limits that shape life on the planet, but adds into it a social minimum safe standard for all of humanity. So the inner circle in that donut is the social foundations for living a good life. It includes things like health and education and having work, having political voice, having social equity, things that we have widely recognized as critical for living a good life. And the donut framework talks about that happy middle ground, that donut, where we are above the safe social standards and we are within the safe planetary boundaries. That's the sweet spot for humanity. So it's adding to the planetary boundaries biophysical framework the additional dimensions of social justice and brings social and environmental concerns together in a common way of thinking. And again, unfortunately, the news on the social goals is not that great. The United Nations has adopted them in the form of what people call the Sustainable Development Goals, and our performance towards them, even before the pandemic, wasn't all that great. And obviously, as we can understand, the pandemic has had a devastating impact on achievements in many of those social goals. I'm, of course, going to be talking much more particularly about hunger. And again, unfortunately, the data suggests that the patterns that we have been experiencing after steady progress through the early 2000s had already before 2019 started to turn for the worse. Hunger in the world, estimated in 2019, before the pandemic, had already started increasing, and we know that the pandemic has had a devastating impact on global hunger. So the FAO, the Food and Agriculture Organization, estimates global hunger in its annual reports, and they think that something like between 700 to 800 million people were probably hungry. That's about 10% of the global population that Mike just alluded to. In Africa, that's 21% of the population and 9% in Asia and Latin America. Given the population sizes, half of the world's undernourished live in Asia and a third in Africa. And in terms of adequate food, not hunger, something like 2.37 billion people estimated by the FAO as not having adequate access to food, 1 in 3 people on the planet. So that set of global trends frames the context for today's lecture. We have a planet in some form of peril. We have GDP accelerating. We have social goals at risk of not being met, and we have hunger accelerating, all on a finite space that we inhabit called this planet Earth. How do we make all of that work together? So Mike referred to the panel on forests and food that I was part of, and this was convened a few years ago, trying to explore the links between something that I'd worked on for a pretty long period of my career, which was forests, and their role in relation to food. There are many dimensions of that relationship, and I'm going to spend quite a lot of time exploring those dimensions. We published our work in 2015. There's been some really interesting follow-up. But it started with just a very simple observation of spatial overlaps between the places that were still intact in terms of having some forest, and paradoxically being the places that were also experiencing the highest amount of hunger. So the maps on the right-hand side is the prevalence of undernourishment. The darker shadows indicate more hunger. And the map on the left is the current distribution of the world's forests. And we were looking at this spatial overlap and trying to understand why is it that there are lots of people who are hungry in the same areas where we're seeing that there's a lot of forest cover. Is there a relationship? What kinds of relationship are there? And one clue to this is to do with the way in which traditional approaches to addressing hunger have tended to neglect the role of the forest. Hunger is addressed through enhancing agricultural productivity on cultivated lands. And the role that forests play in supplementing people's dietary needs has tended to be neglected from national hunger strategies in most countries, despite the fact that there is growing evidence that people continue to rely on forms of wild food, of wild foraging, as supplements to their nutrition. So actually the work that we did then was to try and document what is the role that forests might still play in people's diets, and are we getting something wrong by focusing only on productivity increases on agricultural lands as the sole focus of our hunger strategy? The intention wasn't to say that that's wrong, but maybe it's insufficient. Clearly, we will continue to need productivity increases where large-scale crop patterns are available, where we've got the potential for improving yields. But is that sufficient? And I'll explore in a bit more detail why that might not be sufficient. But I want to start with the more sort of conventional framing of the relationship between forests and agriculture, or in fact, the trade-off between forests and agriculture. When people think about what is driving forest loss, especially in the tropics, one of the biggest drivers of forest loss is the expansion of commercial agriculture. So a recent paper looking at the use of using high-resolution Google Earth imagery was looking at what are the primary causes of the loss of forest between 2000 and 2015, and it finds that it's primarily commodity-driven deforestation and shifting agriculture. So the conventional framing of the forest-agricultural relationship is a framing of trade-off. More agriculture means less forest because they are competing over scarce land. This is also verified in another report by an NGO called Forest Trends, which does a lot of this data collection. Their report last year confirmed the same pattern, that 2/3 of tropical forest loss is driven by commercial agriculture, and a large proportion of that is illegal cultivation in violation of national laws and regulations. So it's not just that agriculture is expanding, but agriculture is expanding in places where it is legally not permitted to do so. So that trade-off relationship frames the question of the forest frontier, the images that we often have of vast lands of agricultural cultivation effectively clearing the rainforest. Those frontier-like images are framed around this trade-off. And what people have often suggested is that there is a sort of succession pattern, that you go from densely covered forested systems, natural vegetation, and over time, as vegetation starts to thin out, you get this secondary vegetation, this mixed landscape, and eventually that gets replaced by monoculture crop cultivation. So there's a sort of transition, and the graph, the green graph, is showing the decline in tree cover across that landscape. So as you go from very dense landscapes towards cultivated landscapes, you have less trees on the landscape. So the suggestion is that there's this progression away from dense natural systems towards monoculture agricultural systems. And a question that's then asked is, what do these different landscape mosaics reveal in terms of the ways in which we can feed ourselves and the ways in which we need to look after nature and biodiversity? And there's a particular debate, discussion around two particular ways in which we could organize the landscape. One is called landsharing, and the other is called landsparing. And those two are seen as alternative visions of the way in which we might manage this agriculture and forest relationship. So land sharing is an integrated landscape vision. It's a mosaic vision of tree and agriculture systems integrated into each other, and the attempt to try and create biodiversity-rich landscapes that also sustain agricultural production. That's sharing the land for multiple purposes. The landsparing hypothesis suggests that we should actually specialize our landscape. Let's set aside land for specialist uses. Let's have agricultural productivity concentrated in places that are the most productive, and let's use that to spare land for other uses, of which biodiversity might be one such use. So you intensify land use, you maximize production in the agricultural landscape, but you release through that maximized production land which can be used for other purposes, of which nature conservation might be one. So there's slightly different ways of thinking about how to organize the agricultural and forest landscape. So that's been a part of the debate. The question that it's asking is, how do we find the best farming method that balances these trade-offs between agriculture and biodiversity? Landsparing focusing on intensive agriculture, that's the diagram on the top. So what you can see there is that the white areas are your agricultural fields. That's where you're getting intensified crop production. The green areas is where you've put all the protected areas on the edge of your landscape. So you've spared the land in order to create these productive, biodiversity-friendly areas. So landsparing is about intensification. It's about often commercial cultivation, which potentially maximizes production on the cultivated landscape and maximizes the space that's available for biodiversity conservation through sparing land. The assumption is that there's a target amount of food that we want to produce, and if you want to produce a target amount of food, if you can intensify cultivation in highly productive landscapes, you will release some land which can then be used for biodiversity. The land sharing approach thinks about a slightly different model in which you're integrating agriculture and biodiversity within the same landscape mosaic, where you're trying to adopt wildlife-friendly farming practices, where you're trying to integrate both the production and the conservation land use within one patch of land. And there's been a lot of debate about which of those is appropriate for which purposes. One of the fathers of the Green Revolution was an agricultural scientist called Norman Borlaug. Norman Borlaug put forward this hypothesis, saying that by adopting things like the Green Revolution technologies, we would increase agricultural yields, which would prevent agricultural expansion, saving natural areas for conservation uses. And the evidence from the 1960s to the present day is that in the absence of the Green Revolution, we would have needed a lot more land to cultivate the food that we currently cultivate. So there's no question that in some senses, the Borlaug hypothesis has been proved correct. In the absence of those technological advances, in the absence of that intensification, the amount of land we would have needed to feed ourselves would have been a lot greater. So arguably, that's saved some land that we have probably been able to put to other uses. The risk here is what some people call the rebound effect. For the individual farmer, there isn't necessarily a target production amount that they need to achieve on their land. If I have 10 acres of land and you double my productivity, I'm not going to cultivate just half my land. If I'm selling into the market, I'll cultivate all 10 acres. So the risk for the individual decision maker is that by offering them these new technological opportunities, you're not necessarily going to limit their production. They'll just expand their cultivation on all available land. That's the rebound. So you're actually expanding the demand for agricultural production because there isn't necessarily a finite target of production that the individual decision maker is aiming at. They're a small player in a large market. So there's a risk that without additional restrictions on how much a farmer can produce, there will be an incentive for them to produce to the maximum available land use. This is where regulations come in. This is where things like the restrictions within the Common Agricultural Policy of how much you can produce were part of a regulated system in which you were not allowed to produce without limit, that the farmer would have additional restrictions in order to generate other benefits from their land use. And really, that's where some of this land-sparing approach has now started to focus. What are the accompanying policy tools that are needed so that the high-yield systems that we are focusing on also generate environmental benefits? They must be coupled with additional policy measures. You can't expect, you can't guarantee the achievement of those additional biodiversity gains from high-yield systems. Because the focus of the high-yield system is maximizing productivity. We can't assume that the high-yield system will also deliver your biodiversity gain unless you have explicit policies that allow those biodiversity gains to be delivered. So in a recent review paper, this is what one of the people who's been very closely associated with this, who is, again, one of our colleagues here in Cambridge, Andrew Bamford, has said, for high-yield systems to generate environmental benefits, they must be coupled with efforts to reduce these rebound effects. For land-sparing benefits to be realized, agricultural intensification must be coupled with conservation set-asides, along with policies that explicitly focus on these environmental aspects of governance. So while land-sparing does generate the potential for biodiversity gain, we mustn't take it for granted. We have to have accompanying policies. And of course, it comes with risk, sadly, very apparent today. Look at those graphs of world wheat production. 29% of the world's wheat is grown in Ukraine and Russia. These are specialized landscapes on a global scale. We have intensified land use in the places that are most productive. But the risk is that this has a profound impact on food availability worldwide. These are the breadbaskets of the world which are at war with each other. So when you have specialized landscapes like this, when you maximize an intensified production, you have a high risk of a food system that is very vulnerable to things like conflict. You could have other factors. You could have climatic impacts. You could have environmental impacts, which are putting at risk the food security of the planet. The other graph there is even more scary. It's sunflower seeds, 61% in Ukraine, 20% in Russia. That's pretty much all of the sunflower production on the planet. So that shows us that sustainable intensification might be potentially desirable, but it also comes with potential risk. What about other forms of managing these landscapes? In many of the parts of the world where I've done primary research in South Asia, for example, but also elsewhere, most landscapes are not that specialized. They're multifunctional. Most landscapes, when we go for a walk with my dog, are multifunctional. They're not only landscapes that are producing one outcome or one output. And in these multifunctional landscapes, you've got multiple objectives that people might want to pursue. So in this graph, and this is based on a study that was done in Ethiopia by some agricultural scientists a couple of years ago, they look at the landscape and they look at all the things that the landscape might deliver. So you have tree cover, you have birds and other animals, you've got crop productivity, you've got feed for grazing animals, you've got fuel because a lot of people derive fuel wood and other products from the landscape. You've got the balance of carbon, so that's carbon sequestration. That is one of the things that forested landscapes might deliver. Dietary diversity, the nutrient content of wheat, and then social goals like equity. The point of this is to demonstrate that what we expect the landscape to deliver is more than just either high crop yields or biodiversity. Most landscapes deliver multiple outputs. And those multiple outputs are valued differently by different actors. The yellow is good, and what the study in Ethiopia showed is that when you start to think about a much more complex set of trade-offs across these wide range of goals, the complex landscape, the multifunctional landscape, is actually delivering more effectively than the simple landscape, which is the sustainably intensified landscape, you'll notice that the crop productivity in the simple landscape is fantastic. So if all you care about is yield, your simple landscape is fine. That's the third one over. But if you care about everything else there, then the simple landscape isn't delivering very well. And what you need are these more complex, multifunctional landscapes. So it depends on what it is that we want this landscape to do for us and who's making those decisions. This is where the political economy questions come in. Because all those outputs, all those values are going to be valued differently by different people. The carbon market is now being valued internationally because every time we take a flight, we offset our carbon emissions. So you've got one set of stakeholders who care about a particular set of outcomes. They want that landscape to sequester their carbon. Another set of stakeholders might care about local dietary diversity or might care about fairness and equity in terms of the way in which the products of that landscape are distributed. So you start to get competing claims over that landscape. And that's the political economy question. Another study did a very similar thing, and again, it more or less makes the same point. So the graph on the left-hand side is a monocultural system in which you get very high crop productivity. So the little arrow pointing to the right is very high crop productivity, but in that graph, not much in all the other dimensions, forest products, livestock, pollination, et cetera. Lots of those don't really feature as outputs from this system. In contrast, this mixed cultivated system is actually delivering on multiple outcomes. So if all you care about is crop productivity, okay, the monoculture might be good enough. But if you care about all the other things, maybe you should be thinking about a more complex landscape mosaic. So people have been focusing on this as examples of what we've been calling integrated landscape initiatives, approaches to landscape management that are trying to explicitly reconcile these multiple objectives: agricultural productivity, conservation of ecosystems, wildlife, improved livelihoods. These are all the things that we want the landscapes to deliver. And that requires deliberate planning and policy tools in order to support these activities. And they require coordination of activities across sectors that have often not spoken to each other. Government agriculture departments and government forestry departments often don't talk to each other. That type of intersectoral coordination is really important in order to achieve these sorts of multiple landscape level outcomes. And we also should start talking to farmers a little bit more. What do they want? And they don't always want to maximize yields. It may be one tool in delivering the outcomes that they want. But farmers may have other motivations. The economic return on their land may not be directly correlated with yields because it depends on how much input you need in order to generate those yields. So your profitability isn't necessarily going to be directly correlated with yield. In an increasingly mobile world, off-farm employment opportunities, off-farm livelihood opportunities might mean that the household decision about how much labor you allocate to the family farm suddenly changes because there are external opportunities. If your younger generation would prefer to work in the city and remit money back, the labor availability in the household dramatically changes. What you're then looking at as a household family production unit is a labor-saving agricultural technology because your big constraint is the lack of labor for the family farm. So you suddenly adopt a very different style of cultivation, and it doesn't necessarily focus on yield maximization. And people want to spread risk. Farmers are risk averse. They want to make sure that there's a production available for the next season. And there are, and we'll see some of these in further slides, there are cultural practices and dietary preferences which might dictate the ways in which people choose to cultivate their lands. So we have to factor all of that into how the farmer chooses to organize her landscape, rather than thinking that yield maximization is necessarily her only objective. So a very interesting recent paper talks about these two debates from the perspective of thinking about the politics of knowledge or the ways in which people generate knowledge, and essentially suggests that these two parts of the landsparing and landsharing debate are actually completely alien to each other. The social networks that produce knowledge on these two sides actually never really interact with each other. They're two completely different epistemic communities. They don't engage in intellectual dialogue other than when they're arguing with each other, because they come from different starting points and they have different value systems. The core belief that drives the sparing approach is that nature and people, or nature and agriculture, cannot cohabit. We have to separate them out. They have opposing needs. We need to block nature off from humans, and we need to allow human space to expand elsewhere. Humans, therefore, are seen as outside of nature. We're separating out the two. The land sharing hypothesis is centered around biodiversity and agriculture as integrated systems. They work together. They can coexist. They are mutually interdependent. You can create integrated systems in which nature and human societies are benefiting each other. And those are very fundamentally different ways of looking at the relationship between humans and nature. And that's the epistemic divide between these two communities. So this is not going to be empirically resolved. This is not a debate that has an empirical resolution. They're philosophically fundamentally opposed to each other. So back to forest and food, which was a really interesting piece of work to do. So we reported in 2015 and got picked up quite a lot in the media. This was quite an interesting kind of process to be part of. And I want to just share some of the insights from there and then bring us back to conservation and food as I close off. So after we did our report, the FAO has something called the Committee on Global Food Security. They took notice of this new role of forests in food production. And actually, what was really compelling as a follow-up from our work was initiated by a forest-based research organization. So clearly, they were trying to articulate the importance of forests for food. And as I said, we felt it had been somewhat neglected in conventional approaches. But for the Committee on World Food Security to ask that same question was really quite powerful, because where they were starting from wasn't at all any interest in forests themselves. But they asked us to follow up to do this report on what role might sustainable forestry play for food security and nutrition. So it's been a really interesting sort of process of thinking about these questions. I'm just going to share some of the motivation initially, and then some of the evidence that we did put forward. Here's the motivation, and I've kind of alluded to this, but here it is explicitly. So we know there have been really impressive productivity increases in global agriculture. The Green Revolution has been dramatic and profound. But despite that, you saw the data that I presented. Global hunger remains a serious problem and is increasing. So conventional agricultural strategies, while they have been amazingly powerful, they haven't eliminated global hunger. When you look at dietary diversity, we find that a number of people have unbalanced diets and they lack nutritional diversity. The Green Revolution produces cereals, but it doesn't give you a nutritionally balanced diet. It's increased the exposure of some of the most vulnerable groups to volatile food prices, with 29% of the world's food grains being produced in an area which is currently in the middle of a conflict. We will see the impact on food prices in the next few weeks and months. And the people who will be exposed to that are the most vulnerable populations. And of course, we know that there are long-term ecological consequences with intensified agriculture in terms of impacts on water tables, impacts on soil salinity, which have been widely documented. So without undermining the gains of the Green Revolution, we have to recognize that it hasn't solved the problems that we continue to face. In parallel, there's evidence that forests and tree-based systems can complement, not replace, our agricultural production strategies. So they can add to what the agricultural production strategies are already giving us. In particular, by offering better nutritionally balanced diets, and I'll share some evidence on that. Obviously, they provide wood fuel, which is critical for cooking, helps to convert food into nutritious food. They offer control over food choices at the local level, because some of these wild forage foods are available in periods when you've got agricultural lean periods, when you've got locally available foods. And of course, there's a complementarity in terms of soil fertility and a number of other factors that forests can provide in terms of enhancing agricultural systems. So we explored that, looking at both the direct roles of forests in terms of dietary diversity and livelihoods, as well as the indirect roles in terms of what they provide in terms of supporting ecosystems and ecosystem services. And the evidence that we started to gather in these two different reports was really quite compelling. A number of studies have documented that people depend on forests, and food is an essential part of that dependence. And the diversity of forest products that people depend on includes not just things that grow on trees, but things that grow around trees, like mushrooms and fungi and lots of other things that we depend upon in various ways. Although rates of hunger in a calorific sense have been falling in many parts of the world, these micronutrient deficiencies of iron, of vitamin, of iodine, which are associated with the poor growth and the poor cognitive development, particularly of young children, continue to be a real problem. That's what people now call hidden hunger. It's not hunger in the sense that your belly is empty, but it's hidden hunger because you're not getting a nutritionally balanced diet. And that gets overlooked sometimes when we talk about food security. So lots of evidence that, for example, so much of the fruit that we depend upon has wild origins and depends on wild origins from both wild and semi-wild stands in native forests, so the continued importance. Of course, we have started to carefully cultivate the things we most value. So we know about cocoa, we know about coffee, we know about palm oil. Those obviously have wild origins, but are now plantation crops that are being grown for human purposes. A lot of really interesting evidence. I'm just going to sort of rattle through a lot of this because it's just interesting, perhaps a little anecdotal, but interesting to recognize how important these things still are. The sources of vitamins, minerals, proteins, fats, and other nutrients. Wild African trees like the baobab, the tamarind, very high in calcium, extremely high in things like protein and iron. The importance of foods like mangoes in Asia and the vitamins that you get from there. The iron content of the African locust bean, the raw cashew nut, which are often compared with the benefits that you might get from eating chicken meat, for example. So there's a lot of really strong evidence that these things can help with this nutritionally balanced diet. People have then tried to do some systematic studies to try and understand whether at scale these things matter beyond the anecdotal evidence. And there are a few studies that find systematically the benefits of living in or around tree-based systems in which these wild products exist. So a study from Tanzania, the first one that I'm citing here, found that children and mothers in households who ate food from forests or who had tree cover close to their homes were documented as having more diverse diets. So proximity to the forest resulted in more diverse diets. Likewise, this Malawi study found that if you lived in a community that had experienced deforestation or children had less diverse diets in these communities compared to where no deforestation had taken place. So the impact of deforestation was to reduce dietary diversity. This was even found to be statistically significant across a 21-country study across Africa. Again, positive associations between the diversity of diets of children under 5 and tree cover in their communities. So these have been reported pretty widely. I've currently got a PhD student who's trying to study this in Northeast India to find out, even in today's 21st century agricultural and production systems, to what extent are people still benefiting from access to forests as a critical part of their food strategies. And importantly, they break the monotony. If you're getting just cereals and that's all you're eating, having access to these wild foods occasionally gives you a slightly more interesting diet. So But they also provide a really interesting safety net, and I've kind of alluded to this in this graph, and there's a lot of detail, but actually what you need to focus on is the graph on the right. What it shows is that there are 5 months in the year where we can call it the hunger season, where agricultural productivity is low, and that's precisely when some of these forest foods become most important. A whole range of them, and what it's trying to talk about is what are the nutritional benefits, vitamins and minerals that you get from these foods. And they fruit at different times of the year, and you can spread your consumption patterns across the year. So there's some very sophisticated systems that deal with the ways in which people incorporate these wild foods into their dietary preferences. I obviously must touch upon something that's also important and topical, which is the use of wild meat, which is still very prevalent. It's often the most important source of animal protein which is available to forest-based communities. It helps to diversify their diets, and it's particularly important where they don't have access to livestock which is cultivated for human purposes. Hunting providing a large amount of the intake in parts of Central Africa, but not just hunting, but also other forms of protein intake. Insects remain very popular on the dietary menus. I believe they're also becoming very popular at some of the most high-end restaurants in Europe. So, at both ends. But insects provide really important proteins and nutrition. The example from Papua New Guinea and Eastern Indonesia is the active cultivation of particular types of trees that harbors these insects, because the insects are a critical part of people's diets. So now that's important and continues to be important. We know that there's a risk. So immediately after the pandemic started, a number of conservation organizations wrote to the World Health Organization calling for a global ban on wild meat hunting. And that raised a really difficult dilemma. The risk, of course, was that exposure to wild meat might be associated with zoonotic spillover from the wild meat species into human populations. That might be what is causing these viruses to generate and propagate themselves amongst human populations. So let's ban wild meat. One of the concerns there is that by doing so, you deny access to wild meat to millions of people who depend on it for their nutritional intake. How do we balance that trade-off? And obviously, there's been a very active debate. We actually have a paper coming out very shortly, which is trying to look at this systematically. And what we find, firstly, is that the risk of zoonotic spillover from domesticated animal production is at least as great as from wild meat. So a ban on wild meat isn't necessarily going to stop the risk of zoonotic spillover, but it will have particular impacts on particular populations in particular parts of the world. So we need to spend a lot more time, and our review finds that we don't know enough about the actual conditions in which zoonotic spillover takes place. We need to focus on what are the conditions that allow viruses to jump from animals to humans. And we need to find ways to control that spillover rather than a knee-jerk reaction, which is to ban all wild meat hunting, because that doesn't actually solve the problem. And it has particular impacts on the populations that depend on these wild meat hunting practices. All it does, and there have been bans in some parts of the world, it pushes these practices underground, it makes them more risky, it potentially makes it even more difficult to regulate these practices. And it has particularly severe impacts on food security in some rural and indigenous populations. So I'm going to close with a few more slides just thinking about the role of indigenous people's knowledge, because it is really important. And knowledge systems that have carefully thought about wild foods for generations. And the importance of us recognizing indigenous knowledge systems as complementary to scientific knowledge generated in the ways in which we do science in the Western world. The observational knowledge of indigenous peoples as a form of a tested scientific approach, and the inclusion of that traditional knowledge in policy, particularly recognizing that their food systems, which have been widely documented, make use of hundreds of species of edible and nutritious flora and fauna that are no longer part of the Western diet and may have nutritional benefits that are being lost to the Western diet. So how can we integrate these indigenous knowledge systems better into the scientific knowledge systems that we are currently using? I've been able to work with the FAO's Global Hub on Indigenous Food Systems, and they've been doing some really amazing work. There was a World Food Security Summit last year. They produced this white paper co-authored by indigenous peoples organizations on indigenous peoples' food systems as a scientific input into the World Food Security Summit, but was based on these indigenous cosmovisions, on the importance of indigenous territorial practices and social institutions. So I'm going to start to draw to a close. I promised to return to Partha Dasgupta. I'm going to use his report to help us to think about what's the big message that I'm trying to communicate in the context of these discussions around food and conservation. And I think it's a message about coexistence. I worry about separating us from nature. And at the end of his review, this diagram is what Partha Dasgupta puts forward. And in his way of thinking, the human economy is now embedded in nature. The model of the economy that Partha puts forward in his report is a human economy that is embedded in the biosphere, not external to it. And if we start to think of ourselves in that way, we can start to think of coexistence rather than trade-offs. We can start to think about the ways in which our food production system and our conservation systems complement each other rather than competing with each other. We need to understand that beyond this crude characterization of a conservation versus agriculture trade-off. This becomes a bit jargony. What we're trying to look to do is to create these resilient, climate-smart landscapes which provide these multifunctional outputs, which prioritize things like food, biodiversity conservation, and livelihoods in integrated systems. That's a great slogan, but how do we actually achieve it is the practical question. But that's the direction of travel, rather than trying to separate things out. We need to shift to understanding the landscape in a nutrient-sensitive way. And this is the difference between nutrient outputs and cereal outputs, nutrient outputs and calorific outputs. What is the nutritional value of a landscape is very different to the yield of a landscape. And let's think about those value chains, moving away from a production-centric approach to food security. Let's give agency to farmers. Let's ask them what their priorities are with the lands that they manage. And let's give priorities to the knowledges that local and indigenous peoples hold. And that might take us towards this model of an economy embedded in nature, which is what Dasgupta has been talking about. Thank you very much.
Well, thank you very, very much indeed, Bhaskar. That was a really inspiring finale to our series of lectures on food. I think the way you set food and hunger in the context of the whole global political economy, our planet's biophysical boundaries as you described them, and ultimately whether we can achieve the UN Sustainable Development Goals or living sustainably was both fascinating and illuminating for us all. You've clearly highlighted the importance, the interdependence between nature and people and the need for integrated approaches to that, and highlighted just how complicated and challenging the dilemmas, the trade-offs are, but I think you've given us hope as well. So thank you very much for that. And on a personal note, I've been lucky enough to work with Bhaskar for the last 14 years on some of these issues, coming more myself from a biological background than a social science background, but it has been really educational, a privilege and inspiring to work with you and your colleagues across this university on these incredibly important but challenging issues that we've talked about. It would be unwise and impossible, for me at least, to attempt to sum up the extraordinary, rich and informative lectures that we've heard over the last 8 weeks, especially when there's food waiting for us, many of us, at least somewhere. But I would like to just conclude with a few brief observations. Firstly, from all the 8 lectures we've heard, I think we've really seen the importance of having a diverse range of disciplines, from climate science to archaeology, to history, to economics, to chemical engineering, to veterinary science, and so on, and how they can all contribute to our understanding of food. All of the speakers have also highlighted the importance and value of cross-disciplinary boundaries in research, and many of them have indeed crossed disciplinary boundaries themselves in their own professional careers in order to understand and answer questions around the topic of food that we've been covering. They've all also brought together experience, knowledge, and analytical tools and approaches from one discipline, and in many cases applied them to another. Secondly, I think we've seen how each of them has explored the interface between research, policy, in some cases politics, and practical actions that are made by companies, by governments, by individuals, and just how important that is in addressing the global challenges of food security and feeding the planet, not only our own species, but enabling and allowing other species to survive upon which we are equally dependent for our own survival. It's been an incredible journey, highlighting both the enormous global challenges, but also the incredible opportunities for innovation, individual action, and the vital role that I think we've all seen research can play in ensuring that we can feed the world without destroying the planet. So I'd just like to conclude this lecture series this year with a few thank yous. Firstly, to the organizers of this lecture series. They took on the significant challenge of organizing a lecture series in the middle of a pandemic, selecting the subject, finding speakers who were by and large confined to their bedrooms at the time, and yet our 3 organizers, Dr. Miguel Anya, a physicist and research fellow at Darwin, who initially proposed the idea, and then very sadly for him is in isolation, so he's joining us online. Thank you, Miguel. I'm so sorry you're not here for this final lecture in person. Dr. T.J. Young, a glaciologist at the Scott Polar Research Institute and a postdoctoral research associate here at Darwin, who is here with us this evening, and Dr. John Nielsen Wright, who is an associate professor of modern Japanese politics and international relations and a long-standing fellow of the college, who isn't here but is in Paris for another commitment, but is also joining us online. So thank you to the 3 of you for putting together such a remarkable and fantastic lecture series. And I should also like to thank somebody else who's online and unable to be with us, and that's our catering manager in Darwin College. He very nobly undertook, in fact he offered, to prepare the meals that those of you who are dining in college after these lectures are able to experience, themed to whatever the lecturer was speaking around. I think when he chose to do that, he hadn't realized just what some of the people would be talking about. But nevertheless, he rose to the challenge along with his team, and we are extremely grateful to you, Ivan, and very sorry you can't be here in person, but delighted that you, along with many others around the world, are joining us online. And then, of course, there's the rest of the Darwin College team and community who make this possible, from our Educational Research Committee, our ushers, our assistants, and our indomitable registrar, Janet Gibson, who for years has been pulling so many strings to make these lectures work. So can you please join me in thanking them and thanking our AV team, both in the college and here in this lecture theatre, for helping to make sure that these lectures remain incredibly exciting and valuable in person, but equally this year available online, live around the world. And now, of course, just before you do go and eat if you can, we have, of course, another lecture series all ready for you for next year, 2023. Please put it in your diaries. So I'm delighted to reveal that the next Darwin College lecture series, oh, I've pressed the wrong button, will be on isolation. So you will see we already have a fantastic array of speakers lined up. It seemed a very appropriate topic at the time, as you can imagine. It seems very appropriate now for a number of different reasons. The world is a tricky place, as we all know, and isolation is an important and vital topic for us to cover. I promise you it will not all be about COVID and isolation from COVID, as you can see. So please do come back and join us next year. But in the meantime, thank you to all of you for joining us online, for joining us in person. We would not be doing these lectures for anybody other than you. It is a great pleasure and privilege for the college to be able to do so, but you make it what it is for us. So thank you very much.